Hi guys, this is Mrs. Foy, and this is a quick screencast on a combined gas law problem. So this is a funny problem, you guys will like this. So here's the problem. A helium balloon is fully inflated at 1.2 liters. When a clerk is filling the balloon, she stops to make sure it's not going to explode and checks the pressure. The pressure is 5.7 kilopascals and the temperature in the store is 24 degrees C. The balloon is 0.75 liters full. She stops when the balloon is fully inflated and the pressure is 7.2 kilopascals. When the customer takes the balloon outside, it explodes. What was the temperature outdoors? Okay, so this is a good example of a problem where the order of the data that you're given in the problem is not exactly P1, V1, T1, right? So you have to read the problem and understand what's happening. So what I understand here is that this is, when the balloon is fully inflated, it is 1.2 liters. So that's going to be the final volume, okay? The pressure is 5.7 kilopascals and the temperature in the store is 24 degrees C. The balloon is 0.7 liters full. Those are all the first conditions, all right? Then she stops when the balloon is fully inflated. We know from the problem that's 1.2 liters, and the pressure is 7.2 kilopascals. When the customer takes the balloon outside, it explodes. What's the temperature outdoors? Okay, so now we can identify all these. We know that the 1.2 liters is actually the second volume. That's the volume in the second condition. The first pressure is 5.7 kilopascals. The temperature in the store is the first temperature condition, and this 0.75 liters is the first volume condition. She stops when the balloon is fully inflated. The pressure is 7.2. That's the second condition. That's P2. And so the question is asking what is the temperature outdoors. So I first of all have to apologize to you guys. I'm making the screencast at home, and so I'm having to actually write these numbers with my fingers, and so that's why they look kind of funny. So anyway, let's take a look at this. We need to take the combined gas law equation here, right? P1 V1 over T1 is equal to P2 V2 over T2. And I know I need to algebraically rearrange that equation so I can get T2 by itself. So my algebra teacher tells me the first thing I need to do is to cross multiply to get rid of my fraction. So I'm doing that. P1 V1 times T2, that goes on this side, is equal to T1 times P2 times V2, that goes on this side. Now I need to divide both sides by P1 V1, and now I know that my pressure units are both the same. I do need to convert my temperature to degrees K, so I do that. So here's my temperature. I have to convert that to degrees K. Here is my final volume. Here is the final pressure. Here is the initial volume and the initial pressure. And so I know the temperature outside is 600 degrees K. Well, what is that in Celsius? It doesn't ask me, but just so you know, if I wanted to convert back to Celsius, then I would just take the degrees K minus 273. And here's where the funny part of this problem comes in. That seems really hot, doesn't it? Well, actually, in Fahrenheit, in Celsius first, that would be 327 degrees Celsius. That's super, super hot. It turns out that that's about 617 degrees Fahrenheit. So that balloon store must have been on Venus or something. That wouldn't have definitely been in Earth conditions. So hopefully this has been helpful, and I'll see you in class.